Hey everyone, welcome to Prep with Sid, where we break down technical interview questions step by step and focus on the thinking behind the solution. Imagine you're working at Spotify. The product team wants to understand how users listen to music throughout the day. Are users listening during one long session or are they coming back multiple times? To answer that, we need to group individual listening events into separate listening sessions. This pattern is commonly known as sessionization. Sessionization means grouping individual user events into separate activity sessions. Interestingly, this exact same pattern appears at many companies. Netflix may want to know viewing sessions. Amazon probably wants to know shopping sessions. Companies that are using Google Analytics data want to find out how users are browsing the website. Uber probably wants to know top drivers by the number of rides, or DoorDash may want to know how many customers order more than one time a day. These questions may sound different, but underneath they are testing the same pattern. We need to look at the time gap between consecutive events. If the gap is larger than a defined inactivity threshold, we start a new session. Let's look at the question. Spotify wants to identify its most engaged users based on listening frequency. A new listening session begins whenever a user has been inactive for more than 30 minutes. Calculate the total number of listening sessions for each user and rank users from most engaged to least engaged. So let's try to understand the question. If I'm listening on Spotify, let's say I listen for 5 minutes, then I take a break for, let's say, 10 minutes, and I again go back listening. That is still considered as one session because in the question it's saying it has to be more than 30 minutes. Then only we consider it as a new session. Now, if I'm listening for 5 minutes and then come back after an hour, now it's a second session. So the result is going to be in the first scenario where I came back in 5 minutes, I have one session. But in the second scenario where I came back after 30 minutes, I have two sessions. The important phrase here is inactive for more than 30 minutes. That means a gap of exactly 30 minutes remains part of the current session. A gap greater than 30 minutes starts a new session. Let's create a simple listening events table. Each row represents one listening event generated by a user. Now let's insert some test data to work with. So this is my test data. I intentionally included a few different cases. So user 101 has 3 sessions. See, the first one starts at 9, then 9:10. Obviously, it is less than 30 minutes, so it's going to be part of the same session. From 10 to 25 is still less than 30 minutes. So it's also part of one session. Now it is going from 9:25 to 10:10, which is more than 30 minutes. So our session 2 starts. Here again, it's after 10 minutes, came back to listen. That's also session 2. And this is a session 3 because there's more than 30 minutes gap. So here we have 3 sessions. For user 2, we have 2 sessions. And for the third user, we only have 1 session. Let's execute this. Okay, we inserted 15 records. Let's inspect the raw data first. This is especially important for event-based problems because ordering determines the entire solution. We need to evaluate events separately for each user and in chronological order. That's why you see order by in my query, even when just investigating the data. If you think logically, forget SQL for a minute. The way you would solve this is by looking at previous event and decide if the previous event is within 30 minutes. If it is, you know it's the same session. If it's not, it's a new session. Okay, let's start to solve this problem step by step. Step 1 is to find the previous event for each user. I'm assuming you know about lag and lead. Lag is used for looking at previous row and lead is used for looking at the next row. So here, since we want to look at previous event, we'll use lag. Then we want to partition by user ID because we are interested in each user's session and not across all users. And we use order by event time that shows user's event in chronological order. Of course, you can imagine for the first event of each user, previous event time will be null because there's no earlier event. Let's try to execute this SQL. This is the result we get from the SQL. So for each user, I'm just adding another column called previous event time. And in the previous event time, you will see that the first one obviously going to be null because there's no previous row. This is the first row. For the second row, the current event time is 9:10, but the previous one is 9. Right here it is 9:25. The previous one is 9:10. So we are only putting the previous event time. We are adding a new column called previous event time. Let's move on to step 2, where we will calculate the difference between the consecutive events, because that will help us calculate if the consecutive event is within 30 minutes or not. Here, I'm using a DATEDIFF in minutes between previous event time and the current event time. Let's execute this SQL. Now we can clearly see how long each user was inactive between consecutive sessions. The first event still has a null inactivity value, which is expected. So far, we have calculated the previous event time and the difference between the previous and the current. Let's move on to step 3. Step 3 is to flag the beginning of every session. Here, we simply want to say if it's a new session or not. And we are doing that using the case statement. The first event for each user must start session 1. So when previous event time is null, we assign a flag of 1. If inactivity minutes is greater than 30, then event begins a new session, so we also assign 1. Otherwise, the event belongs to the existing session and the flag is 0. Let's execute the SQL. Notice that exactly 30 minutes does not create a new session because the requirement says more than 30 minutes. Okay, so we have our previous time, we have inactivity minutes, and we know if it's a new session or the current existing session. Let's move on to step 4. Step 4 is to calculate the total number of listening sessions for each user. And we do that by grouping session flags by user ID and sum the session flag column. Let's execute. So here we can see user 101 has 3 sessions, 102 has 2 sessions, 103 has 1 session. So now we know the number of sessions per user. Now the only thing to figure out now is the most engaged versus least engaged users. And we can do that by using a rank method or a dense rank. You should know the difference between rank and dense rank. I'm not going into it. There's a separate video for that. You can look up the difference between a rank and dense rank. So for this scenario, we are going to use a dense rank because if 2 users have the same number of sessions, we want to show both of them. Let's move on to step 5. Now that we know the total number of sessions for each user, we can rank users from most engaged to least engaged. For this problem, we are defining engagement based on the listening session frequency. So a user with more listening sessions is considered more engaged. We use dense rank ordered by total sessions descending. The user with the highest number of sessions gets rank 1. Let's execute. Here you can see we have our user 101 with engagement rank 1 because it has the most sessions. Now, in a real product analysis, session count would be one engagement signal. Interviewer may change the question based on the listening hours, which would use exact same logic, but instead of summing the sessions, you would sum the listening hours. But for that, of course, you need listening start and listening end times. So to summarize the solution, first, we use the lag to find the previous event. Then we calculate the inactivity gap by using DATEDIFF. Third, we flag events that start a new session using the case statement. And finally, we use sum to calculate total sessions and then rank the result. Once you understand that pattern, you can apply it to listening sessions, website visits, shopping sessions, viewing sessions, driver activity, and many other event-based problems. Hopefully, this made sessionization feel more intuitive. The more SQL problems you break down this way, the more patterns you will start recognizing naturally. And once you start recognizing the patterns, the SQL becomes much easier. Thank you, and I'll see you in the next one.